students. Today we are going to discuss about Wein bridge oscillator circuit. Oscillator circuit is a circuit which generates a sine wave signal without application of input signal. There are different types of oscillator circuits are available. Here we are going to design generate a sine wave signal by using Wein bridge oscillator circuit. This is actually the bridge. As we know that bridge consists of 4 arms. So this is the first arm which is having a parallel combination of RC. This is the second arm having a series combination of RC. This is the third arm with a pure resistive element, and this is the fourth arm which is having a 4 resistive elements. So this is basically a first concept as a bridge circuit. There are total 4 arms as I mentioned. This is again the circuit of a Wein bridge oscillator interface with the operational amplifier. The simplified circuit diagram is shown over here. This is operational amplifier. As already we know that IC 741, OP07 or 356, these are the pin compatible ICs. So we are going to use operational amplifier over here. This R1 is connected between pin number 2 and ground, and RF is connected between pin number 2 and 6. The remaining, so this is the first arm, this is the second arm. The remaining 2 arms are between pin number 3 and 6 we have connected RC series combination, and between pin number 3 and ground we have connected a parallel combination of RC. So this is a Wein bridge oscillator circuit. We have connected plus VCC to pin number 7 and minus VE to pin number 4 of operational amplifier. This is inverting terminal, this is non-inverting terminal of the op-amp. To generate a sine wave signal we need a positive feedback. So between pin number 3 and 6 we have connected series and parallel combination of RC network. Let us consider some basic equation points about the this operational amplifier oscillator circuitry. According to Barkhausen criteria, the total phase shift around the circuit must be 0, and mod of A beta, that is feedback factor and gain, the product must be greater than equal to 1. For a Wein bridge oscillator, the value of beta factor is equal to 1 by 3, and that's why the requirement is the gain A must be greater than or equal to 3. The gain must be greater than or equal to 3, and that's why here the loop gain is 1 plus RF by R1 is equal to 3. That's why the RF by R1 is equal to 2 and RF is equal to twice R1. Let us consider R1 is equal to 10 kilo ohm, RF is equal to 20 kilo ohm. Here actually instead of using a fixed resistor of 20 kilo ohm, we are going to use a potentiometer of 22 kilo ohm value, so that we can adjust the mod of A beta must be greater than or equal to 1. The frequency of sustained oscillation is given as F0 is equal to 1 upon 2 pi RC. Let us consider C is equal to 0.01 microfarad. Then we are getting the value of R is equal to 15.9 kilo ohm. So the components we are going to select as resistor 15.9 kilo ohm, capacitor 0.01 microfarad, the feedback resistor we are connecting potentiometer, and the resistor we are connecting 10 kilo ohm. So these are the components we are selecting, and operational amplifier we are going to use in a circuit. Now let us come to the circuit. This is a dual power supply we are going to use. We have applied a plus minus 12 volt power supply. This is actually the dual power supply we have connected to the operational amplifier, and this is the circuitry where we have connected series combination of RC, parallel combination of RC, and the 2 pure resistive elements in the circuit. This, as I mentioned, this is the potentiometer of 22 kilo ohm we have connected in a circuit, and by adjusting the proper value of resistor, so that mod of A beta is equal to 1, when this condition will get satisfied, we are getting a sine wave signal generated at the output side. So if you see, the sine wave signal is generated at the output side. Its frequency is 970.9 Hz, which is nearly equal to 1 kHz. By considering the design consideration, F0 is 1 upon 2 pi RC. We have selected the component C is 0.01 microfarad and R is equal to 15.9 kilo ohm. The calculation comes out as theoretical design is 1 kHz frequency, and practically we are getting the frequency is equal to 970 Hz. And the peak to peak voltage comes out to be 23.2 volts. That is the saturation voltage. V peak to peak is 23.2 volts. Hence, whatever the objective we have defined, that is design, build and test Wein bridge oscillator circuit for a frequency of 1 kHz is achieved over here, and you can observe the sine wave signal generated at the output side. Hence, the objective is achieved.